Hey guys, I want to talk to you a little bit about the conservation of energy as it applies to the dominoes in my Rube-Goldberg device. Here I've created a little sketch. As you can see, potential energy equals kinetic energy. When you put a domino on its edge like this, you are giving it gravitational potential energy. I did a little investigating. I saw that typically a domino tile weighs roughly 8 thousandths of a kilogram. Gravity, as it always is 9.81 meters per second squared, and the height is 25 hundredths of a meter. Now, typically you might think you want to start from the top of a domino to get the height. However, you really want to start with the center of mass here because that's where the tipping point really is. Now, when I give it a flick, which will go negligible here, you'll see that the potential energy starts off, let me give you a little flip here, with roughly 0.001962 joules, the unit for energy. The formula, the initial kinetic energy plus the initial potential energy will equal the final kinetic energy plus the final potential energy. Now, when that domino falls over, there's a couple of things you have to take into account that we won't hear just because it requires a little bit more math to it. But when it hits another domino, some of the energy is going to be lost with friction and sound. But seeing as how all the dominoes are in a system, we can calculate that from the first domino drop to the last domino drop, all the energy will stay the same and actually be converted into pushing the car down the ramp. I did the calculation here. You can see initially there's no kinetic energy, only potential energy. And at the end, you can say, well, all the potential energy is gone and is pushed into the car, so it'll be zero, but that kinetic energy is what is needed. After a little bit of math, you get yourself the final kinetic energy of 0.001962 joules. And hey, there you go. Energy is conserved, actually resulting in the car being pushed.